So this is the week 5 review. Hello everyone. So I wanted to discuss about why the heck I am doing this weekly reviews, right? So I think many of you would have seen, or you can comment down in the below. So when you are trying to learn something difficult and it takes a good amount of time, say you want to learn guitar or workout, you are trying to do it like continuously every day, or something like machine learning or AI, right? You would have realized it's difficult to be consistent, because when you start, right, first week, 2 weeks, you will be excited about it, you will do it every day, but the problem begins when it's like more than 2 weeks for me actually. And you would have realized it's difficult to stay on track with those things, yeah. uh, so one thing I realized, hmm, this is the, I guess, the third time when I'm trying to learn machine learning and AI to be on that journey. So with my past experience that I've learned, right, it's about appreciating the journey. Okay, when we look at the destination, it's too far ahead. Okay, when we will reach the destination, we think, okay, we should enjoy at that point of time. But with the time, I realized, right, the amount of time I have stopped devoting time to machine learning and I have stopped doing AI, and because that was like 2 times, this is the third time when I'm doing. So I realized that I should appreciate the path which I am doing on. I should enjoy that path of doing that. Okay, that's when, or that will motivate me to go ahead and do that thing. So that's why uh, every week, right, this actually, it's Sunday, so I sit back and see, okay, what I have done in the past week. Okay, uh, what I have learned in this past week. And when I see, right, before start of the week, what I didn't knew, and after a week, every day doing some amount of machine learning and AI, and what I have learned, it's really a positive vibe to it. It actually motivates me. Okay, I'm going ahead, I'm going ahead, I'm going ahead. And it's not that most of the time it's the only thing that is going to motivate you. It's, yeah, sometimes you listen to some motivational quotes or videos or anything. Just as much as of motivation, it can give you, be on that track. And I really wanted to know about all of you. When you try to do something which is difficult and which takes a good amount of time, it leads to your patience, okay, how you go ahead, how you motivate yourself to go ahead. I really want to know. And that was the first reason. The next reason of why I do a weekly review, right? Basically every day I have keep a goal, okay. I should read 4 pages of this hands-on machine learning book, or 5 pages for you if you are say doing a workout. So say push-ups, you try to do, okay, I will do a minimum of 2 or 3. Okay, it's not important how many you're doing, but every day that you are doing. Okay, so that's how I have kept. And based on that, the complete book length is like 270. So 4 days every week, how many months it will take for me to finish, so that every day I have some goal. Okay, and it's not like strict, it's 4. If I do 4 less than 4 also, I will be disappointed, but at least, okay, I will motivate. No issues, I will go ahead. So this weekly review, right, I see in that whole week, means every day, how many pages I read and I met my target or not. So say it's 7 days, 28 pages I should read. At times it is lower than that. Okay, okay, it's okay. If it is going way too less, it's only 20 pages. If I'm able to do, I need to change my strategy, the number of pages I need to read every day, so that how much time it will take again. So it just gives me an overview of the path that I'm following, and I am on that path or not, or I'm deviating it a bit too much. Okay, or if I'm going too fast, I'm reading 5 or 6 pages a day. It's on average, say it's 35 pages I'm reading. Also, I should challenge myself a bit more, so I should keep it as a 6 pages per week. Okay, so something like that. So these are the reasons why I basically do weekly reviews. And lastly, when I go through all of that, right, if I have, means I try to just explain it in summary, every topic that I learn in that week, at least. Uh, it helps that uh, uh, concept to stick in my head a bit more when I try to explain that a little bit. So these are the 3 reasons. Okay, but just to let me know if you, means how you get yourself motivated, okay, or how you stay consistent with everything. Whatever you do, I just want to know that. Okay, so now let's start. So recap what we did in the previous week. So it was classification. So Before that we are trying to predict some sale price or something. Now we are trying to classify this. Classify is like, for you the computer is trying to say you are a male or a female. Okay, it's like classification. For a human being it's pretty easy, right? You see, okay, it's female or a male. But for a computer to make him understand how a boy looks like, the nose, the eyes, the different body parts, shapes and everything. Okay, so you try to classify based on that. So in that way, here also in that hands-on machine learning, the second chapter, so we are trying to classify these numbers. So these numbers are written by some, I think, school kids. It's pretty bad, but yeah, my handwriting is also not anything better than this. So so in this chapter we are trying to classify this, say, this first one, it's a 5 or not, it's a 0 or not, it's a 4 or not. Okay, now next we, what we did is this problem of so many numbers, 0, 1, 2, 3, 4, 5, 9. It was way too difficult to start with and think for a beginner. Okay, if you give him and say, okay, teach the machine to help him understand it's a 5, it's a 3, it's a 4, it was a bit difficult. So what we did is we simplified the problem. So it is only is 5. So this first letter is 5, so it's true. 3, it's not 5, so it's false. 4, false. 3, false. So other are all false, but it's a 5, it's a true. So it's a binary classification. If it is 5, it is true. If it is not 5, it is false. Okay, so we have divided the problem in that way. Okay, to start with. Okay, so now about the dumb classifier. So there are different machine learning models, okay, which we were trying to train and then predict if it is able to do a classification or not. So it was giving us very good number. Okay. You can also really just go to that book and apply all those machine learning. You will get 96, 97%. Now the problem is, was it too easy that you were able to get such good numbers, right? Because if you remember in chapter 1 in the regression, you were getting pretty bad numbers. Okay, 60%, 65%, getting 97% is like, whoa, you have solved the problem. Okay, but this problem doesn't look that similar. So what in the book we did, right, all these numbers, right, they just gave false, 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 false to everything without thinking of what is there for that. Okay, it's a 5, it's a 3, or 4, it doesn't matter, just give it as a 5, let's predict it as a false. Okay, and if you see in this column, when you say if I predict all of them as false, right, when you try to see what is the result, it will be 90%. Why? Because out of 10, 9 are already false, 9 are not 5, only 5 is true. Okay, so only 1 is where you will get a cross mark, which is wrong. Apart from that, all of the other of them are true, right? So you will be getting 90%. Even the dumbest classifier who doesn't know it's a 5 or a 3, or which has done not a single bit of hard work, only it has said false, it is even giving 90%. Okay, so the problem is with the amount of data. So say you have 100 records also, but if you have only 10 records or 5, any the numbers of the classifier will give you 90%. So then the problem came, okay, how to design a metric or a number which can tell us, okay, how good it is, how bad it is. Okay, that's when we came up with confusion matrix. And if you're thinking why it is known as a confusion matrix, right, because all the terms are here, if you see, right, at one point of time they will surely confuse you. You have to be really trying to understand, get means work a lot of time or hands-on with this confusion matrix, then it will be no confusion. But in the beginning it should be confusion matrix. I think that's why whoever discovered it gave it the name. So what in this confusion matrix we do is say this positive and this negative. Okay, this is for a binary classification. So positive means that these are all 5s. Okay, in actually they are 5, and written they are 5. Negative, they are not 5. Now here is what we are predicting. So say this was actually 5. Some of them that comes here we predicted as 5. So they were 5, we predicted 5. Here they were 5, but we predicted it as not 5. Okay, which is bad. This is good, this is bad. That's why it's true, whereas this is false. Okay, now the next line, they were not 5. So what we should have told, that is also not 5. That is good. So here it was a negative, it was not 5, we predicted as positive, mean 5. So it was not 5, we predicted as 5. This is bad. This one, it was a not 5, we predicted as not 5. So it is very good. Okay, now, and this, say we have some 770 rows, okay, of numbers, different handwritten numbers. So there were 123 fives. We predicted them as 5, and they were not 5, we are 520, and we predicted them as not 5. So this is the best we can do, or this is the best possible model, okay, which can do this. And in this case, these both will be 0. Okay, this is the best confusion matrix, and always our target is how close we are to this confusion matrix. If we are like 100%, if we achieve this, that is the best of the best model. But obviously, 100% it's not always possible. So we'll see how we are devising it. So we have few terminologies that we define with the confusion matrix. So one thing that I said here, see, if I'm predicting something as a 5, okay, how many of them are actually 5? That what this tells, and this is where I predicted them as 5, but they were not 5. Okay, so we define a terminology for this. Okay, so as much this precision goes up, that is good. What that means is this true positive, this thing, okay, this is as much it is growing, and as much is this decreasing, the precision will increase. Okay, so you can see TP by TP plus FP, that is the formula for precision. So if TP is increasing, say TP here will also increase. If the FP here decreases, then overall this will be a good number. So if we say precision is high, which means if it is 80%, then it means 80% of the time we are saying it is 5, it is actually 5. The 20% of time it is not 5. Okay, so the more the value of precision is, the more it is good. Okay, now we have something known as a recall. Now recall what it is. So here you see this column, it is recall. So positive, this means actually they were 5. This is where I am predicting them as 5. This is where I am predicted them as not 5. So this is TP by TP by Fn. So if TP increases and Fn decreases, then overall this will increase. So this will mean, okay, if it is going up, it is good. Now there is a trade-off, okay, or I would say it depends. Or okay, let's go ahead. I will explain that later. Okay, so now you have both the terms. Precision is also important for the figure, whereas recall is also important for the figure. So we combine them to create one F1 square. This is known as harmonic mean. Okay, so this takes both the precision and the recall and it gives us a number. Okay, so this is one number. Like in the beginning we are saying getting the dummy classifier and we are getting 90% right. So you can this number to predict, okay, which model is good, which model is bad, okay, based on this number. Now there is a very interesting thing. You understood, right? The precision should also be high in number, whereas the recall should also be high in number, but it's not always possible to do that. There is always a trade-off between them. So there is an example. Okay, now if you would be thinking, right, how this machine is able to predict a 5 or it's not 5. Means it's not a human, right? It just sees that number 5 and it says, okay, it seems like 5. When you give it a 6, it's able to predict, okay, it's not a 6. How it is predicted? So what our machine does, right, it fixes a threshold number, say 0. Okay, say this point here is a 0. Now when we give this digit to the computer, it gets with a number, say 1000. So that 1000, as it is more than 0, it tells it is 5. Now when we give this 5, okay, this is somewhat different from this 5. When we give this to the model, it says it's minus 100 number, that is less than 0. So it will say it is false, it is not 5. Okay, so that's how a binary classification works. It's under the hood, that's how it works. Okay, so what the intention of saying this is how there is a trade-off between a precision and a recall. Say I predicted this threshold. Okay, so based on that, if I give these 5 numbers to the machine, okay, it says them they are all 5. Okay, so now when we try to define the precision is TP by TP plus FP. So what that means is, out of these 5 numbers here, how many of them I am predicting correctly as 5? So there are 5 numbers. Okay, 5 numbers. Out of them I am predicting 4 as 5. So it means my precision is 80%. Now let's see the recall. Recall is how many actual 5 are there, and out of which how many I am predicting correctly. So if you say there are 1 2 3 4 5 6, so there are 6 fives, and I am predicting 4 of them are 5, 2 of them I am predicting wrongly, so 4 out of 6, this is 67%. When we say this, okay, there is a problem now that the amount of fives we are getting is pretty less. Okay, actually there are 6 fives, but we are getting only 4. How to get more fives? So what we did, we decreased the threshold a bit. Okay, we kept it here. Now what happened when we say precision? So now we have 3 5 8 numbers, out of which I am correctly predicting 6 as 5. So 6 by 8 is 75. And when we say recall, so there are 5 actual 5s, out of which I'm predicting all of them are 5. So there are 6 by 6, that is 100. So what happened here, that precision decreased a bit, but recall increased. And the same thing happens when you push the threshold forward bit, right? What is happening, precision is increasing but recall is decreasing. Okay, so there is always a trade-off between the two. So we have to get to a threshold, right, where both are okay in between, and we are happy with that number. We can't always say that okay, precision should also be high and the recall should also be high. Okay, and actually it depends on the problem as well. Say you have been given a task, okay, to predict if a person is a shoplifter or not. Okay, now here say about recall. Now in case of recall, if there are 10 shoplifters, right, if you are able to predict 9 of them are shoplifter, it is very good. Okay, now let's think of the precision perspective. Now precision, we predicted uh, 12 as shoplifter, but out of which only 8 were shoplifters, so 4 were wrong. That is still okay. Okay, you will just go to that person and say okay, you have left something or not. Okay, he will say no, I have not done. You will do the verification, it's okay. It's very important that you should have a high recall in that case. Okay, that shoplifter should not get away. Okay, you should be predicting more, so in that case the recall should be high. If precision is a bit less, it is okay. So it's mostly depends on the problem. Okay, now after that we have one more term. Finally, this is the last term. Okay, so till now this tn was not getting any respect, only these 3 columns were talking. So here the speciality comes to the picture. So it's one my speciality, don't think about it, this one is more important. So what we are doing here is fp by fp plus tn. So what that means is the not 5, say we have 520, out of which how many I am predicting wrongly, means I am saying they are 5 but they are actually not 5s. Okay, so if that number is less, right, means say 520 and I'm saying 1 as 5, whereas the 519 others as 5, that is very good. Okay, not 5. So in this column, right, how, so special one minus speciality is the less it is, that is good. Means less means that there were not 5, like 520 numbers, out of which 520 I am saying as not 5, is they are not 5 and I am saying they are not 5, that is very good. So that, so this number 1 minus speciality, it has to be low. Okay, for precision and recall it was high, it is good. For 1 minus speciality it has to be low. Okay, so that's where we plot this ROC curve. So this is one other way of evaluating the models. Okay, so here is the 1 minus speciality, here is the recall. Okay, so always our intention is to have a good recall, because that is a positive thing, that should be high. Whereas the 1 minus speciality, this thing, okay, it's not written there, but it's 1 minus speciality, it has to be less. Okay, the more it sticks to this line, right, more our graph is near to this, that that is better, that is good. The more say the line goes like this, okay, whereas 1 my speciality is on increasing and the recall is also increasing, that is not a good thing. Okay, recall should be more and this 1 my speciality should be less. Okay, so this is one more way. So say we plot again one more graph here, so which is good, this one is good, which is sticking more to this side. So you can always calculate this area. Okay, so the one that sticks more to this line, right, will have more area. Say this is one more classifier. Okay, so the area around this one will be less than this one. So that is one more way of saying okay, which model is good, which model is bad. So now, till now it was binary. Okay, that the intention was to make the problem easier. Now you want to classify all 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So till now you have spent so much of effort in binary. How to get this multiple classifiers? Okay, so that's where the binary classification means we are smartly using the binary classification to help with that also. So let me tell you how. So what this is one approach. So this is known as 1 versus 1. Okay, so what happens, say we take 5 and we have created 10 different classifiers. One classifier says it is 1 or not, other classifier says it is 2 or not, other classifier says 3 or not. We have trained all of them. Now we give 5 to all the 10 classifiers. Okay, 1 or not will predict some percent. So here say 5 or not predicts 97%. Okay, obviously because it knows it's 5 or not 5. Okay, 3 gets 26% because it is not 3, not other than, means it might be more than that, but it's not 3. 4, 4, how much it is 4? So it is 20%. Okay, so that way what will happen, for every question we ask him, every letter we give him, and we ask for just 10 classifiers, and the one that is the maximum, we will say it is that number. So in that way what will happen here, this will be a 10 columns it will have. We will have different numbers. The one which will be the maximum will be that number. Okay, similarly for 3. So here say it is 5, it will be pretty less percentage. It is 3, the second will be, this one will be more. Is 4, it will be again less. This, if this is the maximum, we will just pick the maximum one, and that will tell us which number it is. Okay, so this is one more way. One other way is 1 versus 1. So this is very interesting. Okay, so what it is, here we train different classifier. One is which says it is 1 or 2. So what we do, say we have 1,000 records. Okay, we will pick all those rows which are 1 and which are 2. Okay, we take it and we say it is 1 or 2. Okay, so say for ones we will tag it as true, for twos we will tag it as false. Okay, so here we will train, if you take all the combination 1 and 2, 1 and 3, 1 and 4, 1 and 5, then 2 and 3, 2 and 4, 2 and 5. So like this we have 45 combination for 10 numbers. Okay, so here what we'll have, the training will be less because we need small data for each. 1 or 2 we will need only those columns which have 1 and 2, only those rows which has 1 and 2. Okay, we'll train our model on that, and we'll again 45 we will have models for each number. We'll try to predict then again the number. Now the combinations like 1 and 2, 1 and 3, 1 and 4, 1 and 5, 1 and 6, 1 and 7, if we are trying to predict one, all those will get more percentage. Okay, rather than the other ones, the 2 and 3, the 3 and 4, the 4 and 5. So we'll combine and get you the result. So this is one more way. It's better in the sense of the other that it needs less amount of data to train, but again it has more number of columns. So these are the two ways, and if you check the classifiers, right, that's how they behave internally. They try to break that problem into the binary classification, try to do that. So I think in the later chapter we'll go in more in depth of this. Okay, so again the error analysis, how we'll do. So we'll create this confusion matrix. Here we have 10 into 10. We'll try to plot that based on the number we have. So if it's more number, it will be white. So as I told you, right, in the confusion matrix, the column has more numbers, whereas the other ones will be 0 0. That is the good confusion matrix, something like this here also. So if you say this is all white and these are all blacks, that is the best model, which is predicting 1, it is predicting 2, it is predicting 2. So so this is one way of looking into it. Just visualize the problem. So say here we get something like this confusion matrix. So we are saying, okay, these columns are so bad. See, they're all black. We are not able to classify this properly. And one here is other line where it is so much white. It means for all the 0 to 9, right, we are predicting 8 more. But this should not be. So based on that, we'll try to tweak the model a bit to make him understand, okay, you should not take the 8 1 different stringent constraints I will put on it, so that how it behaves. Okay, just this gives you a better picture and what you should be doing with the model, or how you should change the model to get a better result of it. Okay, so till now it was all like multiple so many classification. Now the problem increases more, so this is one more type of classification. Now you say you just not want only 5 or not. Okay, you want it is an odd or even or not based on looking at the number. So there are two labels you can say, okay, which is doing that. So there can be multiple labels, so that's why it is known as multiple labels. So rather than is 5, you are looking for odd or it's not, or it's a prime or it's not a prime, something like that. And this is the last type of classification, which is here for every column you had two values, either true or false. In odd or even case, either you will have a true entry or a false entry. Okay, here for each of these elements, right, you can have more than two. Okay, more than two values. So what we are doing here is we have given it a number. Okay, 4, the first number. Okay, so everywhere each of these small pixels you can see, right, there are some values which is from 0 to 255. Now I'm telling him, see, I have given you this number, this was actually supposed to be like this, learn so that when I give you this number you can give me this. Okay, so say we have got a 5 which looks very different, there are black here, they are everywhere. Okay, I'm telling him what should be this number, try to remove all those errors and noise and everything, give me that proper 5 out of it. So that's where we get to it. So these are the different types of classification that we have. So this was mostly the second chapter. We'll go ahead, right? It's interesting. I mean, at least we are playing with the real world data. Till now it was all seen price, lot of columns and values and everything. Here mostly you're interacting with how people, there's handwritten notes, or you can take different photos and train to see how many people are there in that. So this was more or less related to what you see in that Facebook. If you see the tagging mechanism, I think under this hood there will be some sort of classification that will be going on. So this was it. This was the week 5 of it. So pretty interesting, because these numbers and images and removing all those noise and everything, right, it was interesting. So something new. Okay, so that's it. So we'll stop it here, and next time we'll see you with the week 6 review. So bye bye.